Mhm. Hello everyone. Um, so I would like to start my final project presentation, and my chosen project is insurance company complaints, resolutions, status, and recovery. So I have done this project under the guidance of Professor Chelsea Wang, and this is Vandana Buduru, and my campus ID is EY32090. Okay, so let's start the presentation. Um, what is basically the insurance? As we all know, insurance is important as it ensures that we are financially secure to face any type of problem in life. And this is why insurance is important part of financial planning. Insurance is necessary to have financial security, transfer of risk, complete protection of you and your family, and in order to get the peace of mind, and in order to handle and tackle and be at a point of situation where you are able to face any kind of unexpected threat or emergency. Insurance is most important in everyone's life, as we know, and normally insurance is offered to secure health, travel, motor vehicle, and home. So data set. So I have provided the link. I have chosen the data set, and the data set which I have chosen contains the rows 24,842, and it has 12 columns. And I would like to briefly explain step by step in detail explanation of all the columns. And company, this is the name of the insurance company. A particular client is holding a file number, a unique file number that corresponds to the client complaint to identify the client's complaint easily. Open, this is the date on which complaint is registered. Close, this is the date on which complaint is resolved. Coverage, whether the client is holding individual insurance or holding to a family insurance or so. Subcoverage, it tells us particular client's insurance covers how many types, say suppose travel or health or life, etc. And the reason, what is the main reason of the complaint? So just the overview of the complaint. Sub-reason is in detail explanation of the complaint. And disposition, whether the complaint has moved further, like whether the complaint has escalated for the further resolving or say disposition. Recovery, it tells us whether the complaint filed regarding the claim has been recovered by the correspondent company or not. And status. So currently I'm working on the so currently I've worked through entire project on the status variable, and the status mainly tells us of whether the file has been closed or in progress or escalated further. So this is the goal of the project. So my project aims at building a complete project which analyzes the listing of consumer complaints filed against insurance companies licensed in a particular city. So this application can be used by any agency, insurance industry, stakeholders, or the general public to predict the status of the consumer filings against the insurance company. Main aim is to develop an end-to-end data science application that is used by insurance industry stakeholders to predict the status of the problem, status regarding their insurance policy issues. So I would like to explain you in brief with the help of an example. Say a client, a consumer X has filed a file number, say 001, and this is a kind of an application where the consumer X can log into the application with all the necessary credentials, and so with the help of the file number provided by the client side, so say the consumer X can type his or her type of file number into the respected field box, and then you know uh, the consumer X is shown whether the complaint filed is in which state. Say suppose whether the filed number has been closed, or it has been resolved, or it has been escalated for the levels, or it is still in progress, or it is still somewhere stuck in a situation due to no proper evidences. So it just tells what's the status of the file number to the consumer as soon as they opens the application. So I have chosen this process and implemented in the same way, step by step as mentioned. Define the goal is nothing but defining the goal. Getting the data is importing data set with and all the necessary libraries packages have been installed. Cleaning the data. Data cleaning is done, which includes summarizing the columns, detecting the null values, and visualizing statistically. Enriching the data has been done where extra unnecessary columns are removed, just minimized to the level that is needed, and filling all the null values. Mapping with necessary Boolean values is done. Finding insights and visuals. So performing exploratory data analysis is done in this step. Um, and required that we are testing and exploratory data analysis is done in this step on required parameter that we use for testing and training purpose, and we draw assumptions for ADA. And then deploying machine learning algorithms. Machine learning algorithms are applied to improve the performance of the model and comparing efforts scored with other algorithms. I have used decision tree, k-nearest sniper, SVM, and XGBoost and random forest algorithms. Generated F1 scores for all the algorithms and compete with other algorithms and drawing inferences. So, and then exploratory data analysis. So, I would like to just have a brief walk on the EDA which I have done, on which parameters and what I have drawn analysis in final. So, the following graph depicts the complaints filed by year. So, as we could see clearly, 2021 is the highest year where consumer complaints got reported, followed by 2018. And in the year of 2015, there are no complaints that has been recorded at all. So this is the graph, same as the above, but the preceding graph I have depicted it by yearly on the year basis, but this graph I have depicted on the monthly basis. So in the following graph displays complaints filed per month. In the month of January, most consumer complaints were reported, and the in the month of, as we could see, in the month of June or July, so there are typically the less amount of complaints that are filed. And then this is the graph that displays complaints filed by resolved year. So as you could see, 2018 and 2021 are the years where most of the complaints got resolved. And this is the displaying complaints filed by resolved per month. And March and January are the month where complaints got mostly resolved. So this is plotting the bar graph for coverage type and its individual counts. Say private passenger have an individual count of 7,000, as we could see, that is travel and home insurances. Are the most looked at insurance software insurance policies. And this is a bar graph plotted for disposition types. That is reasons for disposition of the claim or policy. It is basically related from the point of view of company. So company puts in substantiated has the highest value. So this is a bar graph for claim reasons, and as we can see, complaint filings are due to majorly for improper claim settlements. So this graph illustrates the same thing as above, but instead it shows in terms of complaint status versus the filed year. And in the year of 2021, most of the complaint status has been closed, and 2022 is the year where most of them was have been reported. And then depicting reasons and the percent of share in complaint filing. So it's just same as the before graph, but it is showing in terms of percentage. So as we could see, claim handling that is due to improper claiming as settling. So most of the files have been filed. Plotting the variation in reason versus recorded amount. So as we could see clearly, claim handling segment is the most highest segment with high recovery amounts, then followed by complaints due to marketing and sales segment. So this is the graph of the variations of recovery amounts with respect to reported year. And this graph shows and collects these records and illustrates which year is the most claims settled year. And as we could see, 2018 is the most of the claims that has been recovered. And this is the graph that shows the variations of recovery amounts with respect to reported month. And as we could see, February is the month with highest sum of claims reserved. And this is a graph showing the distribution of recovery amounts. And as we could see, 2019 and 2022 is the highest amount of where the company has distributed the recovered amounts. So this is a graph showing the variation of complaint status versus recovery amounts and reasons filed. So I have taken three variables into the account, and I found that highest recovery rate is from claim handling with all the complaints has been resolved. And this is the correlation matrix, and we can see that perfectly linear correlation between uh, the two variables. And then I have done feature engineering. So, so why feature engineering? Feature engineering, it enables us to build more complex models than we can do with the raw data, which allows us to build interpretable models from any amount of data. And feature selection has also been done, which helps us to limit these features to a manageable number. And I have done chi-square test, which is used to determine the difference between the observed data and the expected data. Is due to a chance or if it is due to a relationship between the variables that we are studying. And then interquartile range. So before performing interquartile range and chi-square test, I have done and treated an outliers removal. What is outlier? As we know, outlier is basically a point in a data set that is far from all other observations. So it is an observation that lies an abnormal distance from other values in a random sample of a population. So outliers may be treated by box plots, scatter plots, X-scores, IQ, or interquartile range. And then I've used interquartile range as practice. So the interquartile range is when a dataset has outliers or extreme values. We summarize the typical value using the median as opposed to the mean. When a dataset has outliers, variability is often summarized by a static called the interquartile range. So, which is the difference between the first and third quartiles? That is the 75th percentile minus first quart, 25th percentile, and it is shown clearly in diagrammatically. And then what is feature scaling and why feature scaling is done and why standardization and normalization helps to. So feature scaling is a technique to standardize the independent features present in the data in a fixed range. It is performed in a data pre-processing to handle highly varying magnitudes or values or units. So say if feature scaling is not done and only feature engineering is done, and then when we apply the machine learning algorithm, it's not the case. But if feature scaling is not done, then machine learning algorithm tends to make greater values higher and consider smaller values as a lower values regardless of the unit of the values. There are five mostly used feature scaling techniques. And so in order to maintain a balance between between the values and in order to not to tend to weigh greater values, so we have chosen some feature scaling techniques. So there are five feature scaling most techniques: absolute maximum, minimum maximum, robust scaling, standardization, and normalization. So I have chosen the standardization is one of those techniques that the mean of the attribute becomes zero and the resultant distribution has a unique standard deviation is the mean of the feature values and is a standard deviation of the feature values. So normalization is nothing but it is also known as minimum maximum scaling. So x max and x minimum are the values are the maximum and minimum values of the features respectively. And the values are shifted and rescaled, so they end up ranging between 0 and 1. And then machine learning models. So machine learning models have been applied. So I have chosen evaluation metric as F1 score. Um, Okay, so the metrics such as precision, sensitivity, recall, specificity, F score, ROC curve is used to evaluate the binary or multi-class classification problem. So why I have chosen F1 score as evaluation metric? So I have splitted the data for testing and training purpose. And then, as I said earlier, I have applied machine learning algorithms. I've taken F1 score as evaluation metric as the data set is I found the dataset as imbalanced, so I have chosen F1 score to take as an evaluation metric. But also I have plotted ROC AUC curve also for all the algorithm just for visualizing purpose. So that's it. So first is the logistic regression. Um, so by performing logistic regression onto the testing and training data, so after implementing logistic regression, after fitting logistic regression, have received F1 score as 94.1% with AUC score as 96%. And I have applied logistic regression using rich search cross validation and linear solver. So I have got F1 score 94.1% with 10 folds cross validation and linear solver and AUC curve as 92%. And next algorithm which have implemented is logistic regression using rich search cross validation and Saga solver. So for this, I have got F1 score 94.1% with 10 folds cross validation and add to penalty. And then I've implemented k-level records, which have received F1 score as 99.1%. So, which is the same with the logistic regression and logistic with research and logistic with Saga solver. So there is no case for overfitting or underfitting and training in accuracy and test accuracy so close to each other. And F1 score when compared to the logistic regression, k nearest neighbor has weighted better, that is with 99.1%, as we could see. And I have got AUC comes as 99%, which also tells us which is better than the logistic regression before. And then decision, I have applied implemented decision tree algorithm. And for this, I have received 99.1% using decision tree, which is better than logistic and k nearest neighbors. And for AUC a curve, I have received 100%, which is better than the k nearest neighbor algorithm. And then decision tree algorithm, decision tree with Saga solver, decision tree with grid and then random forward. So here also training accuracy and test accuracy are close to each other. So there is no case for of overfitting or underfitting. F1 score is 99.1%, which is better than logistic regression and k nearest neighbors and quite comparable precision training. So XGBoost also I have received same F1 score as 99.1%, which is better than logistic k nearest neighbor and quite comparable decision tree and random forest algorithm. And SVM F1 score I have received 96.9% using SVM classifier, which is better than logistic regression and k nearest neighbors, lower than the decision tree, XGBoost, and random forest algorithm. So these are the outcomes, and This is just the overview of what the models have used and how much is the F1 score I have received. And we could see the percentage have received for F1 score. And I would like to mention once again as well, I have chosen F1 score as my evaluation metric. And just showed tagged critically, or I thought it would be good enough if we also visualize and show the AUC curve. So, but the main evaluation metric is F1 score. So these are the conclusions I have drawn. So by comparing all the implemented models, so I conclude that the k-nearest neighbor decision tree random forest XGBoost classifiers has improved the performance of the model and any one of the models can be chosen for practical business application. So further improvements might be done, and it's better to have a business understanding of the data and how the CBOT the data is. So the results can be improved by having vast knowledge on the business domain, which could be useful in understanding and pre-processing the data. Thus, the outliers and any random noise can be removed. So more advanced algorithms like CNN, neural networks, along with TensorFlow models can improve the performance of the model. Thank you. So this is my final project presentation. Thank you. Thank you so much. So these are the references I would like to mention. Thank you.